Good morning students. Today we will discuss about Kronig penny model. Before going to this, last class we have discussed about Bloch theorem. In Bloch theorem, how potential varies? Potential will be maximum in between the ions and at the ions the potential will be minimum. Now, according to Kronig penny model, he has considered periodic potential varies like infinite square wells. So it varies like infinite square wells. So here in between 0 to A, this is the distance between two ions 0 to A. Here potential is 0. At the positive ions potential is 0 and in between positive ions potential is maximum. So from 0 to A the potential is 0. This is region 1. Next, here in between minus B to 0, it is the potential barrier, means it is the height of the potential barrier. Here potential is V0. This we consider as region 2. Now in region 1, that is 0 to 0 less than x less than A, the potential is 0. In region 2, that is in between minus B to A, it is the potential is V is equal to V0. Now we know the Schrodinger wave equation. What is the Schrodinger wave equation? The Schrodinger wave equation in one dimension is d square psi by dx square plus 2m into e minus v by h cross square psi is equal to 0. This is equation number 1. So this is the Schrodinger wave equation. Now in region 1. So in region 1 is from in between 0 to x less than A. So in region 1, what about the potential? Potential is 0. This is equation number 2. So substitute 2 in 1. So if I substitute second equation in 1, I will get this equation as d square psi by dx square plus 2me by h cross square psi is equal to 0. So this equation I can write it as d square psi by dx square plus alpha square psi is equal to 0. Alpha square psi is equal to 0. Where alpha square, I have considered alpha square as 2me by h cross square. So this is equation number 2 and this is equation number 3. Whereas in region 2, V is equal to V0. This is the height of the barrier. Okay. Now this is the condition. The condition for region 1 is minus B less than x less than 0. Here B is called as barrier width. Width of the barrier. Okay. Now the potential is V is equal to V0. So this is equation number 4. Now substitute 4 in equation 1. So if I substitute equation 4 in equation 1, I get d square psi by dx square plus 2m into e minus v0 by h cross square psi is equal to 0. So this I will write it as d square psi by dx square. Here I will write it as minus beta square psi is equal to 0. Minus beta square psi is equal to 0. This is equation number 5. So what I have taken it as beta square? Beta square is equal to, I got here minus, means what I might have taken. So beta square is equal to, I have taken it as 2m v0 minus e, not e minus v0, v0 minus e h cross square, since v0 is greater than e. So this is the value of beta square. This is equation number 6. Now here according to Bloch theorem, this is the one form of Schrodinger wave equation. This is another form of Schrodinger wave equation. So according to Bloch theorem, what is the solution of those two? So according to Bloch theorem, the solution of, according to Bloch theorem, the solution of equation, what are the equations I have? So this is equation number 2 and this is equation number 5. So according to Bloch theorem, the solution of equation 2 and 5 can be written as psi kx is equal to e power ikx ukx. So I'll write this one as psi x or otherwise you can write it as, so it is a function of x, we know that. So I can write it as, instead of writing psi kx, I can write simply psi. Psi is equal to e power ikx uk. E power ikx uk. This is equation number 7. This is equation number 7. So now I got the value of psi. So I got the value of psi. If I substitute this psi value in equation 2, if I substitute this psi value in equation 2, I will get one equation. If I substitute this psi value in equation 5, I will get one equation. So I will get equations. So see here, substituting 7 in 2 and 5. So if I substitute 7 in 2 and 5, we get 2 equations. So by solving 2 equations, Kronig penny got the solution. Kronig penny got the solution as, so see here, by solving these 2 equations, Kronig penny got the solution as, see here, by solving these 2 equations, he got the solution as beta square minus alpha square divided by 2 alpha beta sin h beta b cos h beta b so he got the solution as sin h beta b sin alpha a plus cos h beta b cos alpha a, which is equal to cos k into a plus b. So this is the solution he got. So this is equation number 8. What is the solution Kronig penny got? Beta square minus alpha square by 2 alpha beta sin h beta b sin alpha a plus cos h beta b cos alpha a, which is equal to cos k into a plus b. So this is the solution he got. From this big solution, he was unable to give conclusions. Okay. So this solution is modified. This solution is modified by making some assumptions. This solution is modified by making some assumptions. Okay. So what are the assumptions he made? So see here, as b tends to 0, v naught tends to infinity. As b tends to 0, v naught tends to infinity. But v naught b remains finite. Means here if b is there, you keep it as 0. If v naught is there, you keep it as infinity. But if v naught b both are there, don't take these values. It remains finite. Don't substitute these values. It remains finite. Because v naught b is the potential barrier. So it remains finite. Now, so next assumption is, if sin h beta b is there, if sin h beta b is there, take it as beta b. If cos h beta b is there, cos h If cos h beta b is there, for cos h beta b, take it as cos h beta b, take it as 1. Okay. So these are the assumptions. What are the assumptions? As b tends to 0, v naught tends to infinity, but v naught b remains finite. So if sin h beta b is there, keep it as beta b. Cos h beta b is there, you keep it as 1. So the above equation, equation 8, reduces as, so equation 8 reduces as, see here, beta square minus alpha square divided by 2 alpha beta, sin h beta b can be written as beta b. So we can write it as beta square minus alpha square 2 alpha beta. Sin h beta b can be written as beta b into sin alpha a, plus cos h beta b can be written as 1 into cos alpha a, which is equal to cos k, see here, cos k a plus b, but b is 0. So I can write it as cos k. This is equation number 9. So this is equation number 9. Now, so see here. Now I want to solve what is beta square minus alpha square. So what is beta square? What I have taken it as beta square in the last equations, equation 6, beta square I have taken it as 2m into v naught minus e by h cross square, and alpha square I have taken it as 2m e by h cross square. So from equations 6 and 3, so from equation 6 and 3 I can write it as 2m, what is this one? 2m v naught minus e. So beta square minus alpha square is equal to 2m v naught minus e by h cross square minus 2m e 2m e by h cross square. This is from equations 3 and 6. This is from equations 3 and 6. So I can write it as beta square minus alpha square is equal to 2m v naught minus 2e by h cross square. So here 2m into v naught minus 2e by h cross square, which is similarly equal to 2m v naught by h cross square. 2m v naught by h cross square. Okay. So beta square minus alpha square value is 2m v naught by h cross square, since v naught is greater than e, means when compared to v naught you can neglect e. So this is equation number 10. So substituting 10 in 9, we get, so substitute 10 in 9, we get beta square minus alpha square means 2m so beta square minus alpha square means 2m v naught by h cross square divided by 2 alpha beta into beta b sin alpha a plus cos alpha a, which is equal to cos k. Okay. So what happens? This beta get cancelled. This 2 get cancelled. So we are left with, see here, we are left with m v naught b divided by h cross square. M v naught b by h cross square. See here, what I will do is, here sin alpha a, here alpha also there, divided by alpha. This is the remaining term. But here I'll multiply with A and I'll divide with A. So mv naught Ba by h cross square sin alpha A by alpha A plus cos alpha A is equal to cos Ka. Okay. So this is the equation after modification. Now, so what I got? mv naught. So what I got? mv naught Ba by h cross square sin alpha A by alpha A plus cos alpha A, which is equal to cos Ka. So this I'll write it as P sin alpha A by alpha A plus cos alpha A, which is equal to cos Ka. So this is the modified equation of Kronig penny. From this equation we can get the conclusions. So this is equation number 11. So where what I have taken it as P is equal to, I have taken it as mv naught Ba by h cross square. So this I call it as scattering power. This is called as scattering power. So this is the solution for Kronig penny. So see here a graph is plotted. Graph is plotted in between. This is the LHS of equation 11 and this is the RHS of equation 11. So a graph is plotted between LHS of equation 11 with respect to alpha A. So a graph LHS of equation 11 with respect to alpha A and RHS of equation 11. RHS of equation 11 is cos Ka, which lies between -1 to +1. So the variation of a graph is drawn between LHS of equation 11 with respect to alpha A. The RHS of equation 11 lies between -1 to +1. So see here, when we see the graph. So this is the graph. So this is the graph drawn between P sin alpha A by alpha A plus cos alpha A with respect to alpha A. Next, the right hand side of equation 11 lies between -1 to +1. So these are the zones we got. So this is the graph. These are the zones we got. These are the zones. So what happens? These zones we call it as allowed bands. Means these are the allowed bands where electron exists. Next, these gaps we call it as forbidden bands. Forbidden bands means where electrons doesn't exist. These we call it as gaps. So these we call it as forbidden bands where electron doesn't exist. So this is the graph we got from Kronig penny model. From this Kronig penny equation we got the graph. From the graph, this is the energy spectrum. From this energy spectrum we can say that it consists of both allowed bands and forbidden bands. Allowed bands are separated by forbidden bands. Okay. So next class we will see for the conclusions. Thank you.